Yeah.
You're still not listening.
Alexei isn't?
Lexi's not, and neither are you. So like I can't
You have
click
to go on air first, so like make them.
I'm on there now.
Yeah. So.
I'm gonna invite you again because it's stupid.
Oh, it says live. Just click that. I get a YouTube video of the being on air, and I see your face,
Yeah.
and it's about 30 seconds behind. Okay, so you had to invite me. I'm gonna mute myself because it's about to get crazy.
We have not started audio yet. We will do that pretty soon here. All right, we're still waiting on getting Alexei in here, and then we will start in hopefully about 5 minutes, so everybody knows. For Chris's information, no one knows how Google Hangouts works, but we're slowly deciphering what it does.
That'd be better. You're killing me.
Great, we'll get started here shortly.
Hey.
Hello, Alexei.
Hi. How are you?
Can I have headphones on?
Throw
So,
a wrench in this by making you hook up.
oh my goodness. Alexei, can you hear me?
Yes.
I cannot hear you. You may want to check your audio settings. Let me also check.
Can you hear me now?
How we doing? I know Orion. I apologize. I'm going to say that name completely incorrectly. I am going to plug in, which is going to change my resolution and break everything. So just one moment here. Oh my goodness.
Can you hear me?
Alexei, up at the top, next to the at the top there, you will see the gear in the middle of the screen.
Yeah.
You may need to change your default microphone.
Can you hear me now?
Settings. This is always our fun part of Google Hangouts,
Hello.
where we make everything work again.
Hello.
I'm going to full screen this bad boy.
Hello. Can you hear me?
Everyone, meet Alexei.
Hey. Can you hear me okay?
Ah, there you are, Alexei. Welcome.
Oh, that's good. Good.
All right.
Thanks for having me.
Thank you. All right. So the deal is, over on the left-hand side of Google Hangouts, you will see a green box with an arrow in it. It pops up on the fancy menu, and you can share slides however you want to do it.
Yeah. I'm trying to.
And I will give a quick kind of overview of what's going on. So the plan is it's 12 Eastern time right now. We'll go about an hour. You can go all the way up till 1 o'clock. We have Q&A turned on, but there were some requests last time to make it available for everyone to speak. Unfortunately, that tends to not work terribly well with the on-air Hangouts. So we're going to continue to use the Q&A to ask questions, and then towards the end, as soon as you're done, Alexei, whenever that happens to be earlier, that's fine. We'll switch over, and I will read questions out, and you can answer them. Does that sound like a plan?
Yeah, sure.
Okay.
I'm
cool.
having a problem with this green button. I'm clicking on it, and then nothing appears. No menu appears.
Nothing appears. Are you? I'm reticent to say. Let's see here. We do hide profile eject. I'm not going to do any of those things to you. I am going to do something scary because I can't see that side. Oh. It's still going. Hey there, Alexei. So when you click on the sharing, it doesn't work. Is that what you're saying?
Yeah, it doesn't.
Okay, I know this is going to be a terrible question. Alexei, are you a Chrome user, a Safari user, or what?
I'm currently on Firefox. It used to work in Hangouts previously.
Google Hangouts just had a bunch of changes.
I don't know. Let me try. Yeah, let me try to reconnect.
Yeah. This will be interesting. Sorry, everybody. We always have this fun. This is part of the wonder of Google Hangouts.
I bet screen share maybe just be a Chrome thing.
Yeah. Hey, there I am. All right, folks, we're getting real close, we believe. Hey, Alexei's back.
Hey.
Hey.
Oh, yeah. It's fixed now.
Oh, it works. So you can hear you. How about the screen? Oh, look at that. Fantastic.
Can you see it all right?
We do. Yeah, it looks great.
Okay.
All right, so right now it is, great question. It is 12:05 our time, so our Eastern Standard. So we'll go for about 50 minutes or so, and then we'll start to do Q&A, or just let me know when you're ready to do Q&A, and I'll start reading them off. In the meantime, I am going to mute. There you go.
Okay, so am I live now? Should I talk?
You're
okay,
good.
Okay, thanks. Hello, everyone. My name is Alexei Sholik, or simply Alex, and today we're going to talk about building command line apps in Elixir. So let's get started. A few words about me. So I've been doing game development most of my career so far, but and I have experience primarily in C family of languages and a little bit of Python. But just 2 years ago, I got Elixir got my attention, right? So and it was it just seemed a very interesting language. Someone called it Ruby with pattern matching. Right? So I never did Ruby, but it got my attention, and since then I've been contributing to it from time to time. And right now I have ended up getting a job writing Elixir code. So I'm really happy about it. And in this talk, I would like to share some of my enthusiasm for Elixir and to show you how to do something a bit unusual with it, not build another web app or stuff like that, which is Elixir most suitable for right now. Right, but in this talk, we're going to build a command line app. Okay, so this is a brief agenda of what we're going to learn. First, we're going to look at we're going to answer the question of why build command line apps. Then we're going to see which types of command line apps we can build with Elixir and which tools are available for this. So here I'm using the CLI acronym. I know this is not a technically correct acronym because it stands for Command Line Interface, but it's just simpler to call command line apps CLI apps. Okay, so let's start with motivation. Why write a command line app? Well, it just happens to be an established standard in the development world, where a simple utility that reads from its input and writes to its output can be used along with other utilities. Right, so these are just the basic traits of command line apps. So an app that reads from its input, writes to the output, and it can be given a bunch of arguments that it parses on launch. Okay, and most importantly, the ability to interact with the OS and other applications. For instance, using shell pipes. Okay, so like I said, they're just useful, and command line apps can be used like in different environments without having some platform installed in that environment first. Okay, use Elixir to write command line apps. Well, if you are going to use Elixir on your server, for instance, if you are writing a backend tool, right? So you have Elixir installed on your server, and usually we don't want to have many dependencies. So if we have a platform installed, we might as well use it to write all kinds of apps that are used in development or during deployment in production and so on. And Elixir is itself a very powerful and very nice to use language. So it provides the standard library that is rather small, but it has all the conveniences you need to start writing your programs. And more importantly, Elixir inherits all of the libraries and ecosystem from the Erlang world. Right? So all of the stuff, all of the problems that have already been solved in Erlang, we can use out of the box with Elixir. And apart from being functional and concurrent language, which is important to write in simple code that solves complex problems, Elixir also inherits the error handling model from Erlang. And here I want to emphasize this simple error handling model, because in Elixir we can manage resources by abstracting them as processes. So if we have an open file or a connection to a database, this connection or this open file can be represented as a process with which we communicate. And if we need to close the file, or if there's some error occurs and the process crashes, when the process terminates, the file will be automatically closed. So by building a supervision tree with a bunch of processes, each of which manages some kind of resource, we can have scenarios where we need to terminate a set of tasks. So we just terminate one process, all of the processes linked to it terminate as well, and all of the resources get closed. Okay. And last but not least, since we're using Elixir, which runs on the Beam virtual machine, we can run programs that run other programs on different machines because it has distribution built in. And we will see this later on today in the demo. Okay, so let's look at what kinds of command line apps we can do with Elixir. So I will talk about 4 main kinds. Let's start with mix tasks. So mix is a build tool for Elixir. It is a build tool and also a task runner. It has a bunch of tasks, like for getting dependencies, for compiling the project, for running tests, and it also allows building custom tasks for it. So here, for instance, 2 examples: it's mix release, which is just a task provided by a third-party library that creates a release from a mix project. Mix docs can extract doc strings from your code and build an HTML page with documentation. So here's a basic template for a mix task. It's just a module that calls use mix task, and we just need to call it so that mix can store a bunch of attributes on our module. Then the short doc is used as a single line description of the task when it is shown in the list of all tasks. And the module doc will be used for the full help of the task. Right? And it should implement one function, which is run. It takes a list of arguments and does something with them. Okay, so let's see an example of this. I have an umbrella app here with some predefined projects. And we just open a mix project, which implements the module. This is the same module we have just seen, right? And what we are going to do, we're going to compile this project. Right. Okay, so we see a list of all tasks, and somewhere there is our task. Let me try again with grep my task. And here we see that our task is showing. So having passed to it. Oops, sorry. Fix my task. Okay, so it just prints the arguments it received in the run function. Okay, I deeply apologize. I need to take a break for just a few seconds. I'll be back in a moment.
All right. So we'll come back in just a brief second here. In the meantime, just for kicks, I'm going to see if we can get the chat working on the left-hand side or in the Google app. So bear with us while we give that a try. So I have now turned that on. James, I think you're on. If you want to try writing something in the chat.
Yeah, I'm back. I'm back. Sorry.
Go for it, Alexei. It's all yours.
Sorry, I just had a brief cat emergency. It's all fine now. Okay, so we've seen how we can build a custom mix task. Okay, but this task is just a compiled module, so a Beam file, and this file resides in our project, in our current project. So if you move up one directory and try to run mix my task again, mix won't find it, right? So that's just something to keep in mind. Okay, so and this is just showing what we just did. So there is a way to package our task and install it system-wide so that it will be available wherever mix is available. So we can use archives for that. An archive is just a bundle of some Beam files. So Beam files are compiled Elixir code that compiles to bytecode, which is stored in Beam files. We can package those Beam files into an archive and install them with Mix. And by doing that, Mix will load all of the archives that are currently installed when it runs any task. Right? So we can do this with our project. We can go back to our Mix task example. We can run Mix archive build. Right? So it compiles our project and creates an archive. An archive is just a single file. And we run Mix. Now we have it installed. Here's the path where it's stored with dot mix. Now we go again up a directory, type mix, and now it works. So, okay. This is a simple way to make any code available to Mix. Like it doesn't have to be Mix task. You just if you create an archive with a Mix task, Mix will be able to see it in any directory. Okay, but there is an important caveat. Mix archives don't package dependencies, so it's mostly useful for simple tasks where you don't have any dependencies. And another caveat is that when you upgrade your Elixir version, previously installed archives may break if there were breaking changes in the Elixir. But this shouldn't be much of a problem after 1.0 is released, because it should be stable enough for archives to work. Okay, and this is an example of the archive that most of you already know. It's called mixhex, and well, it's actually not the task mixhex, but let me get back to this demo. A bunch of hex-related tasks. So hex is a package manager. It can download packages from hex PM, and it can do dependency resolution. And it is normally installed as an archive in your .mix directory. Right, so we can see we have hex here. Okay. Now let's move on to eScripts. So an eScript is a way to create an almost standalone tool. So this opportunity is provided by Erlang. And by creating an eScript, we can package together our project with all of its dependencies, and even with the Elixir library into a single script that will be run, that will only depend on the Erlang being installed on your machine. Okay, so in order to create an eScript, we need to do a single thing. We need to add an eScript configuration to our mix.ex. So in our project definition. And there is one required argument, which is main module. We pass it the module that implements function main. Right? So it's similar to mixtask, but in mixtask, we need to implement a module that implements function run. But with this script, it's function main. It also receives a list of arguments. And there's a bunch of other options there as well. So we type mix help script. Sorry. Yeah, we can see it supports a bunch of options, right? One of them is embed Elixir, which allows us to include the whole Elixir library and Elixir runtime into our eScript. And I have an example of such an eScript, which is called miniweb. So we can run it like the usual Unix utility, right? So it works like a command line app, provides some help message. And this utility is just a general purpose tool that can serve a directory in the browser as HTML, and it can print incoming HTTP requests. So I just built it in Elixir, created an eScript, and now it can be used like a normal command line tool as long as you have Erlang installed on your system. So let's see what it looks like inside. So it's just a bunch of binary data, but the first line we can see is the shebang line, which invokes which invokes this file with eScript, and eScript comes with Erlang installation. And the contents of this file is just concatenated beams of all of our project, of these project dependencies, and Elixir itself. So if I scroll to the bottom here, we can see the names of Elixir modules. So the whole Elixir library is packaged in this single file. And this file, let's see, is roughly 2 megabytes. So that's roughly the size of Elixir library. Okay. So yeah, this is just shows that we can build an eScript after we have added the config option for eScript in our mix.ex. We can build it, and soon we should be able to invoke mix-script install and provide the URL of a hex package. So we should be able to upload eScripts as hex packages and install them. Not implemented yet, but I have provided a link to the announcement on the mailing list that describes this feature. Okay, and lastly, we will take a look at releases. So releases, they come from Erlang, and they are a way to package the whole app into a single bundle, including the Erlang runtime system, and deploy that whole bundle to a remote server where it can be run without requiring to install Erlang first. Right? And I have tried to abuse this functionality, in particular the functionality of bundling the runtime system, to create a standalone command line app. So an app that wouldn't depend neither on Elixir nor on Erlang. So I have a proof of concept implementation, but it's still an experiment. So there's a tool, release tool, which is a third-party library called EXRM, which provides the mix release task. And I was able to play with this to something like that. So we run mix release, and we get a rel directory, which includes the Erlang runtime system and our app. And it has a launch script, which works just like UWeb we've seen previously. Right? So I think there is an ability to make it work, to make a solid implementation of this, but this is still an experiment. So for now, let's do a brief recap. For now, the best way to create a general purpose command line tool would be to create an eScript. Yes, it does require Erlang to be installed, but in all other respects, it works just like a normal command line tool would work that you would implement in C or another language. Okay, so yeah, mixed tasks are mostly used in development. So for cases when you need to interact with the project source or with project configuration, so things like mix docs, mix release, they all interact with the mix project to do something, and they enhance the development workflow. So you can create an archive for your mix task to make it available to multiple projects. And you can create an eScript to create a general purpose tool. So like we've seen with UWeb, it doesn't interact with mix projects at all. It simply provides some functionality. Okay. So let's now switch to a brief overview of tools that are available for writing our own command line apps. So there are two parts to this. First one is building the command line interface, and the second one, interfacing with existing programs. So what does building a command line interface involve? When your application started by the OS, you get passed a list of strings, which are the arguments that are passed during invocation. So, and we need to give some meaning to this list of strings. In other words, parse it, right? And there are a bunch of libraries available for this. So option parser comes with Elixir. It's a built-in module. I have also found getopt, which is an Erlang library that implements an old-school Unix-style command line parsing. And Commando is a little bit more higher-level library that I have implemented, which we will show an example of a bit later. Okay, so here I have just a few examples of how each of those libraries is used. With option parser that comes with Elixir, we define a bunch of switches that our tool will support. So this is, we have a switch name and a type of the switch. We can also define aliases that are just shortcuts for switches. And then we create a list of arguments, and we call option parser parse, passing the arguments and options. Right? And we always get back a tuple of 3 elements. The first will be a list of parsed options. So here we can see we got flag1 parsed because it is an alias for f. And also Elixir supports this convention of saying null flag2 for Boolean options. So flag2 is parsed as the second argument will be a list of arguments. We have options and arguments. So if we get something here like full bar, we will get full bar here. List is a list of invalid options. So here we have defined opt A as integer. So it should take a number. But we pass to it, and therefore joined in the list of invalid options. So when using option parser, we can do a case construct and match first on the third argument or third tuple element to see if we have any invalid options and report an error. And then we can proceed using the arguments and the parsed options. Okay, so this is an example of using getOpt. getOpt, again, this is an Erlang library that implements standard Unix-style command line interface. So we just define each option. Each option is a tuple, which has some fields with predictions, and we can, again, we pass a list of arguments to getOpt parse, and we get back again, we get back a list that looks somewhat. We actually get back the tuple. The first element is a list of options, but some of them may not be. Maybe without arguments, like this one, XML. And we get a list of freestanding arguments. So notice here that all of the strings are actually char lists. They have single quotes around them. So this is because this is an Erlang library, and in Erlang it is historically char lists have been used for strings. So if you want to use it from Elixir, you need to convert them to binaries. And lastly, a brief example of using commando. So superficially, there is not much difference from the getOpt example. But the notable differences here is that instead of tuples, it uses keyword lists. So you actually name each field that you are passing. So here we have an option. Well, first of all, we have our command definition is simply a keyword list. We give it a name, and we give it a list of options. So we have an option called dpName, which has the default value and help message. We have a bunch more options, and we also define the arguments. So, and I'm passing this list to commando new. What this does, it takes this definition, validates it to see if there are any typos or any errors. Right? If there are no errors, it creates a data structure that can be later used to parse the command line. So here I'm passing a list of arguments and this command specification to commando exec. And it returns a struct with arguments, options, and it also supports some subcommands. So if we defined a subcommand, we could invoke that subcommand from the command line, and commando would automatically parse it and return it as a struct as well. Okay, so sorry, I got a little bit of a lag with my wheel. Okay, so let's briefly look at our getOpt demo. So this getOpt, the same example I showed before. You can see that it provides the function parse, getOpt parse, and it also provides getOpt usage. So this is something that option parser that comes with Elixir doesn't give us. So if we invoke it from the command line, we can run it like this. Right, so we can see it outputs a nicely formatted help message for our command based on the options that we have defined for it. So, and similar thing, the commenter does a similar thing. If you can open it real quick, you can see this is the same command definition we had, and has exec function and also help function that can print the formatted help message. So let me show you that. Okay, so again, this uses the help strings we provided to it earlier. So if I go back to the source, you can see that each option has a help message associated with it. And Commander simply uses this to build the complete usage message for the command. Oops. Okay, so we briefly looked at the tools available for us to build command line apps in Elixir. Now I'm going to show you a demo of such an app. This is a toy example, meaning that I'm not using it. I have built it for the purposes of this demo, but it showcases some building components that you will most likely need for a command line application. Okay, so here is our problem statement. We want to write a command line tool that will run tasks on an improvised computational cluster. And by running tasks, I mean spawn external programs on different machines. So here are a few examples. This tool is called Squawk, because why not? And here we can invoke the sort command. So this is the sort that we get from Unix. So just our standard sort, right? Oops. Sorry. Okay, so we can invoke the sort on a random node that is connected to our computational cluster currently. And we can pass to it input from a local file. So again, we're launching this command on our local node, and we have a file stored locally, but we can pass input from that file to a remote node where it will get fed to the sort command, and we will get back on our local node the sorted input. Okay, so a few more examples. So we can specify which nodes to run a command on, right? And here we will be able to. So here we want to spawn grep on 2 nodes, right? And we want to by lines between the 2 nodes. So the input will be each second line will be fed to the B node, and well, we will split the input into lines, right? And every other line will be fed to another node, like that. Okay, so let's see this in action. Okay, so I have a tmux window here, and here the first and the second panes on the bottom, they are running in the Vagrant, locally running Vagrant. And the third one, we will connect to a real VPS that is located in New York. So let me show you that I'm not messing with you. Here you can see my browser, and this is my DigitalOcean account. And here I have this droplet, which is located in New York. Right, and I will copy its IP address, and I will log into it. Okay, so I'm logged into it. Now I will start a remote node. Okay, so I will be using Docker. Docker is just, it allows me to pre-build an image that includes my application that I have built, right? And this image can be run on all of these remote nodes, so it will be an identical, application. So I have a pre-built image that I'm now running, and I'm running a Docker container now, and in this container I will Yes. Okay, so let's see it. So in this container I have Elixir installed, and I will run IEX giving a node name to it so that it can be connected. It can be connected to other nodes, and I also pass -s mix to start my project, which is the same Squawk project. Ooh. So it seems I already have another node here running, left over from my previous experiments. Okay, so let's try with this one first. Okay, so I'm running this here. And this will be our bar node. So this is the same IEX invocation with a name. So now we have a name node running in the background. And I will do the same for the second one. This will be our full node. Okay. Okay, now we will try running some commands from our examples. So one thing I need to mention is that list of nodes stored in a nodes.txt file. So I'm going to remove this third node now because it didn't work. Okay, so I'm going to launch Squawk run. Okay, so this is our command. We want to run the command echo hello on all of the nodes. So these are all nodes defined in the nodes.txt file. And here it shows us that it runs on the nodes bar and full, and we get outputs from each of the nodes. Right, something more interesting that we can run. We can run. I have a prepared info that just has some lines in it, right? And we can grab that file. So I'm going to do Squawk run. I'm going to put it line by line, and nodes full and bar. Okay, I'm going to pass the I flag so that it reads from the input, and I'm going to say I want to filter by the word green. Okay, and I'm passing this split input text tag. Ooh, sorry. This should be nodes. Okay, so again, we are launching a local Elixir node. We are feeding it input from a file, and on the remote nodes, we run grab green. So each node takes some part of the input, and it processes it through grab. Okay, so from the first node, well, from one of the nodes we got green back, green smoke. From other of the nodes we got the rest. Okay, so this is basically what this tool does. Pretty fun. And what I would like to show you is, I would like to walk you through the basic architecture of how this tool is implemented. So we get back to the slides. These are the main components that we are using, that we need to implement. So we got a glide parser, which we will use command of read. Node communication comes with the beam, so we don't need to implement that. We will be using my library Porcelain for spanning external processes. And that's it for now. Okay, so first thing we need to do, we need to pass command line arguments. So I'm going to go to the mix project of this Squawk utility. And so first of all, it is configured to be built as an script. So it has this script configuration that says that the main module is squawk.cli. Also, we have our dependency set here. So I'm going to this squawk.cli module. And here, the first thing is the complete definition of our command line interface. What I will feed to commando. And here, we define a bunch of commands. So one of the commands will be run, and it has a bunch of options defined. Right, and notice here, so I have this module squawk.cli that implements the main function. So this is the minimum required functionality to make it into any script. And here what I'm doing is I'm taking this spec, which is a keyword list of options, and I'm calling command new on it. and I'm setting the result as a module attribute. So what this means this means that the value returned for command in view will be stored on the compiled module. So at compile time, we will get our specification compiled. If there are any errors, like typos, for instance, if we mistype something, we would get that reported at compile time. So once we compiled, we got our specification ready to go. And then at runtime, we simply need to run, to use it to run commando exec. So here, I'm passing my command line specification that is already compiled, and I'm assigning actions to commands. So we have commands defined, and here I'm assigning callbacks. So these are real functions that will get executed by commando when a certain command is invoked on the command line. Right. So this is just the design choice I made with commando. So we have a completely declarative description of the command line interface, and then we just need to do a little bit of post-processing at runtime to parse the arguments. Most of the work commando will do for us. So let's look at our run command. When it is invoked, it gets passed two arguments. The first one is this is a struct for our run command, right? So it has its own set of options and arguments. And this is the top-level command, so the squawk command itself. Okay, and all we are doing here is we do some more post-processing that commando couldn't do for us to build up our argument list. So we will then, after we have parsed the command line arguments, we start our node. So the local, we need to start the local node to be able to connect to the remote nodes. So the start node simply fetches the host name from and does node start. So this all comes in with Elixir. Okay, and next we are calling spawn nodes, passing it our nodes, to be precisely passing it the list of nodes that have been passed on the command line. The command line and the input option that says whether we should read from the input, and so on. So this was our first two steps actually. We have parsed the command line arguments, and we have started a local node. So now we need to connect to remote nodes to be able to run applications on them. So we go back to our tree, and here we'll look at util real quick. So this is just a utility module that connects the current local nodes to remote nodes. So it reads the list of nodes from the file that we provide, right? And then it simply runs node connect. So this is basically what it does. It runs node connect to get all the nodes of the remote nodes and the local node connectors. So then we can call functions on remote nodes seamlessly. Okay, so once we have connected, we can start running. When the squawk run is invoked on the command line. So after connecting to our nodes, there are multiple choices. So if we want to run command on any node, we pick a random one. If we want to run on all of the nodes, we call the run list function and pass it the remaining arguments. So let's take a look at what a run list does. So you currently need to look on these two functions, run list and run multi. So run multi uses the built-in RPC module to invoke a function on all of the modules that we have in our list. So we have a list of modules here, which are just atoms. So they are atoms of the module that we are connected to. And we invoke a Porcelain spawn shell. So here I have put the actual function call. So if we were to call this function locally, we will do it like this: porcelain.spawn shell and pass it the arguments. But since we're doing an RPC, remote procedure call, we're using a slightly different format, but the idea is the same. And what multi-call does, it calls the same function with the same arguments on all of the nodes. Okay, and we get back the result of the function invocation. And what I would like to stress out here, or to emphasize here, Porcelain is my library that can spawn external processes, and it supports a bunch of options when it comes to sending inputs to it or getting output out of it. And out of it, I mean out of the external program that Porcelain runs. So here, we're saying that we want to get the output of the program that we launch sent to our process as messages, right? And the input will be sent as input to the process that Porcelain.spawn shell creates. Okay, so in other words, there is no notion of processes running on other nodes here. So we simply talk about processes, and we don't care whether they run on the local node or on the remote node. We will just use message passing as usual, and it's going to just work. Okay, so once we're done with run multi, here it was. So we get back the following value, which is the values from all of the nodes that have successfully executed our function, and the list of bad nodes, which we're going to ignore for now. We will use it later to just print the fact that the node couldn't run our program. Okay, so we got a prox. A prox is a list of process structs. It's something like this. So this is our spawn shell call. And what we need to do, we need to feed input to all those processes. Remember that we said that the input will be sent to the processes as messages. Okay, so what we do here, so this is the case where we don't have any input. We simply, for each process that we have, we send it an empty string. And in Porcelain, this means that the input stream should be closed. Or in other words, set an e off to it. So if this is true, this means that the program should read input from the standard input of squawk. Then we simply read the whole input into a string and send that to all of the processes. So, and this is send input is just a small wrapper. Sorry. Let me find, oh yeah, here it is. So this is just a small wrapper process send input. It sends the input and then it sends the empty string to indicate the end of file. Okay, so, and in the case where we split the input file into lines, it's implemented here. So here, let me show you the example again to remind you of what it looks like. So again, we're passing input file, we're splitting it by lines, and every other line gets sent to a different node, right? And all of the nodes are running the same command. Okay, so going back to the code, this input line is just a loop, a recursive loop, that prints a bunch of lines. The number is 1 by default. Okay, using standard IO functions. So if we dive deeper, we can see that it calls io.guess, right? So to read a single line, we accumulate n lines, and when we got a bunch of lines, we just take the next process that we have in our list, and we send the lines to it, and then we loop back to our feed input lines. Okay, so, and I'm using a trick here. So the procs, originally this was a list of the processes that we have spawned on remote nodes. And I'm passing that to stream cycle to be able to select each subsequent process indefinitely, so to say. So a stream cycle returns an indefinite list, indefinite lazy sequence of these processes repeated. And then I just take a process from the head of that lazy sequence, send input to it, and then I drop it to get the next process on the subsequent iteration. Okay, so let's get back to where we were. Okay, so we have spawned external processes, we have sent them input, and all that remains to do is collect output. So let me remind you what this looked like. So again, we spawned our external processes with spawn shell, and we said that we want to receive output as messages to our process. Self returns the feed of our current process. So here is our runner. After we spawned our processes and fed the input, we need to print results. And we're going to dive into that function. And here we see that the bad nodes are just printed out, saying that they failed. But the remaining results are our processes. And we're calling, all we're doing here is going through the receive loop to get back all the data that is returned from remote nodes to our local nodes. So this looks exactly the same as if you were running the remote process on a local computer, right? But in our program, it runs on a remote node. But since processes and messages are transparent in Erlang and in Elixir, so they can communicate between computers using the same, basically the same code. So thanks to that, we can write the code that looks like a normal locally executed code, but it will work with remote nodes. Okay, so here we output our data, we loop back to wait for more data, and when we receive the message that says that the external program has finished, we simply print that the status with which it exited. Okay, so again, our squawk run, we say to run on 2 nodes, we send input to 2 nodes, and we get back output from both of the nodes. And this all happens, basically I just showed you most of the code that does all of that. Right? So we've seen how the processes are spawned, how we feed input, how we print outputs, and that's all the code. All right. So I hope that was interesting. I will put up this project on GitHub a bit later, so you can play with this if you want. And I will also add some comments. So you might have noticed I didn't have any comments. I will add them, so it's easier to navigate the code. Okay, so now that's basically all I had to say today. So I just want to sum it all up nicely. Okay, so I have outlined the landscape of CLI-related tools. So you should be able to decide which kind of CLI app you want to write with Elixir, and you have pointers to some of the tools that you can use for that. Right, and the goal here was to experiment and have a little bit fun with Elixir. Right, it is a powerful language, and it builds on a powerful foundation of Erlang, Erlang OTP. But we just use that power to build something fun without constraining ourselves to a traditional notion of what a command line tool looks like. Right? So normally you would write one using a shell script or a C or a dynamic language, but because dynamic languages have library modules that allow users to build command line tools easily. But I just wanted to show you that it can be as easy to do with Elixir, and the fact that we were able to do some distribution here, so to spawn programs across machines, this is just another interesting thing about Elixir. So you get a lot of power out of the box. Even though I should put a little disclaimer here that spawning remote nodes and connecting them across internet is not safe, and when a link between 2 nodes fails, they won't get reconnected automatically. So this worked for our toy example. In the real world, it would be much more complicated, but still it worked, and it was fun to play with. Okay, so if you have Elixir installed, you might as well use it for whatever you find interesting or whatever you think is interesting to make. And I'm just hoping that many more people will try to do something with this, and in the end, the whole community of Elixir users will benefit from it. So perhaps we will be able to fill some niche that is currently lacking libraries. But in general, we will get a better language, a better ecosystem, and a more diverse community. Okay, so I think that's all I have. Yep, thank you.
Great. Alexei, if you don't mind, leave that up on the screen for a little while so people can grab your information.
Sure.
So if you have questions, the Q&A should be up feel free to drop questions in there. I have a couple of questions, and then we can go through some of the ones that come up here in a short bit. The one question that's on top of my mind right now is around the RPC call, and how your Docker instances or even your DigitalOcean instance was set up. Did you deploy your project in that Nix environment before starting up those nodes, or is the RPC multi-call push anything down? So how did that work?
Yes, I had the project code copied to all of the nodes, right? So started this. So here I'm passing .smix. So I'm currently on this node. I'm in the directory of the project, and when I'm starting IEX, I'm starting the whole project up. So yes, you need to have your modules on all of the nodes to be able to call functions remotely.
Okay, awesome. So one of the other questions is around the slides. Are your slides and code samples going to be available?
Yeah, I will put up all of the slides. Well, this is basically a single file, text file, and the code samples will also be on GitHub. So I will post on this Hangout page on Google.
Yeah, if you let us know, we'll tweet them as a part of when the video is available as well, so that everybody can.
Okay. Okay.
Are there any other questions regarding Porcelain or packaging eScripts or anything like that?
Well, I see Chris's question. Chris asks, is there any planned inclusion of Commando features back into option parser? So I don't think so, because option parser is intentionally kept simple, and it only has those features that are used by other Elixir tools, like Wix itself and the Elixir compiler. So, and Commando, it does work right now. So it implements, it gives you more power out of the box, but still this is just one approach, one of many possible approaches to building command line parser. So I'm not entirely happy with it. It's still an ongoing experiment. So yeah, this is just a third-party option, third-party library that anyone else could come up with a similar solution for their worldview of how command line apps should be implemented. Okay.
Awesome. All right. And all right, so I think that's, let's see if we have any other questions. They're going to kind of go in between chat and Q&A. That looks like it's about it. I would imagine by the end of today, the YouTube video will be up. After that, I will probably edit it to get rid of the opening fun of trying to tame Google Hangouts. And then we'll get the slides and everything up. For those of you who have been on the Google Hangouts, we have more coming next month. I will put the schedule out pretty soon. That's going to be... Oh, there's another question. Great. Let's see if I can get back to the Hangout. There's another question here. Are you aware of any libraries for building command line interfaces you would like in curses?
A library like in curses?
Curses?
Well, I know there is an Erlang library. I think it is called ncurses with E.
Oh, yes, ncurses.
As the first letter. Yeah, I don't think there is an Elixir solution for it yet. But there was a user, there was a person, I don't remember their name, who is building a mod in Elixir, so MUD, multi-user dungeon. And I don't know what they're using, but it looks something similar to ncurses.
Okay. Well, certainly everybody that out there, go browse Alexei's GitHub repo. There's a bunch of good stuff out there, including Porcelain and Commando, and some other good stuff. And then obviously these samples are going to be coming our way as well. So thank you very much. We'll be back on again next month, the first Tuesday of September. I don't have the date, but we'll be tweeting it out. So follow Dayton Elixir, and we'll send links out. All right. Take care, everybody.
Thank you.
Thanks, Alexei. It was awesome.